Hi there, boys and girls. Today I'm going to give a name to what we are doing with finding rectangles and approximating area under a curve with a rectangle. And this is called a Riemann sum. This comes from George Bernard Riemann. He's the one that developed this process. And what we're going to do is we've got a curve here and we're looking from 1 to 5. And what we want to do is approximate this area. Now in a few days we're going to figure out how to find the exact value. But for now we're approximating. We have to learn how to approximate, especially when we can't find exact values. So I wanted you to see that if you want to find the area under the curve, the first thing you want to do is you want to break it up into however many rectangles you want. Here we're going to have just 4 rectangles. So you just draw a line up to the curve from each one of your x coordinates. And then based on the problem, it will tell you whether you're supposed to use right rectangles or left rectangles. This determines which one of these endpoints gets to determine the height of the curve. I'm sorry, the height of the rectangle. So this first partition is from 1 to 2. If you're using right rectangles from 1 to 2, 2 is on the right of 1, so that is why we go from 2 up to the curve, and that determines the height of the rectangle. And then from 2 to 3, looking in this partition, 3 is to the right, so that's why we use that as the endpoint. And then 4 is the right, and then 5 is the right. Now if you're using left rectangles, that means that from 1 to 2, 1 is on the left. So the function value at 1 determines the height of the curve, and then the function value at 2, and the function value at 3, and the function value at 4. This is what we did yesterday in class. Now today I'm going to do 2 more. I'm going to show you midpoint and trapezoid. Now midpoint means you're not picking the left or the right, you're picking actually the middle. So on this first interval from 1 to 2, we don't use the function value at 1 or the function value at 2. We use the one right in the middle. The function value at 1.5 gets to determine the height of the curve. And then from 2 to 3, we use the middle to determine the height of the rectangle. See, we're using the middle to get the height. That's what midpoint means. And then if we're using trapezoid, this is actually the best approximation of these 4. You just connect the left and the right endpoint and you find the area of those trapezoids. I'm going to show you some example of these, but before that I want to go ahead and do an example from like what we did yesterday. I want to use a Riemann sum. That just means we're approximating the area under a curve. Under y equals natural log of x from x equals 2 to x equals 4 using 4 subintervals and right hand endpoints. So the first thing I'm going to do is figure out the width of each rectangle. So my delta x is b minus a over how many rectangles I have, which is 2 over 4, which is 1/2. So I need to go by halves. From 2 to 4, I need to go by halves. So let's go ahead and write that in. So I'm starting at 2, and here's 3, and here's 4. So I also need some points in between. I need a 2.5 point and a 3.5 point. So let me draw my, or at least my partitions. My first one up to the curve from 2, and then up to the curve from 2.5, and then up to the curve from 3, and up to the curve from 3.5, and up to the curve from 4. So I have, let's undo that one. I didn't like that one. Up to the curve from 4. That's a little bit better. You can see we have 1, 2, 3, 4 rectangles. Now we have to use right hand endpoints. So this first interval is from 2 to 2.5. 2.5 is on the right, so it gets to determine the height of the rectangle. And then I'll draw this in here. I'll finish filling in those rectangles in just a minute. So this is a rough sketch of what we're trying to do here. So that would be right hand endpoints. Notice this is going to be an over approximation because this function is increasing. So let's write out what this should be. This should be f of 2.5, the function value at 2.5 because I used right hand endpoints, times 1/2, plus f of, that's the first rectangle. The next rectangle goes from 2.5 to 3, and we use f of 3 because we're using right hand endpoints, times 1/2, plus f of 3.5 times 1/2, and then finally plus f of 4 times 1/2. And so you would go grab your calculator and you would actually find the natural log of 2.5, the natural log of 3, the natural log of 3.5, the natural log of 4, and multiply through and add, and you get your answer, whichever one that is. So I'll let you use a calculator and do that. Just wanted to show you a reminder. So now we're going to do a new one. We're going to use a Riemann sum, and this one is going to be midpoint. So I want to show you an example of that. First thing we're going to do is do our delta x. Our delta x is b minus a over the number of rectangles. So that just works out to be 1. So we're going to go from 2 to 6 going by ones. So I'm going to go 2, 3, 4, 5, 6. I'm just going to use those. Alright, so let's go up here to the curve at 2, at 3, at 4, 5, and 6. Now midpoints means we have to use the number that's in the middle. Now our first interval is from 2 to 3. The number that's in the middle of 2 and 3 is 2.5. So I go from 2.5 up to the curve, and that determines the height of my first rectangle. Well, let me undo that one. It decided to do something weird there. Don't do the weird thing again, please. Thank you. Alright, and then on the next interval from 3 to 4, we go up to the curve from 3.5. And that is the height of this rectangle. Fill that in here. And then on the next interval from 4 to 5, you go from 4.5 up to the curve and use that as the height. Go across again and down. And then from 5 to 6, the midpoint is 5.5. When we go up to the top, touch the curve there. So there are 4 rectangles. I realize it looks like 8, but the midpoint thing got drawn in there. So let's see here. I'm going to write out my function notation. I am going to use f of 2.5 times the width of the rectangles. I'm talking about this is my first rectangle. So f of 2.5 times 1 plus f of 3.5 times 1. There's your next rectangle. Notice that the height of the rectangle is f of 3.5. And then plus f of 4.5 times 1, and then plus f of 5.5 times 1. And how you get these values is you grab your calculator and you plug 2.5 in for x to get those y values, and then multiply and add, and you get your answer. So again, I'll let you do that. So that's a midpoint. Now let's do a trapezoid. And the trapezoid, I didn't even give you an equation. We just got a table of values. So I'm going to go ahead and plot these points. X equals 1, y equals about 2.6. X equals 2, y equals 3.4. 2, 3, about 0.4. X equals 3 up to 5.8. 1, 2, 3, 4, 5.8. And then x equals 4 all the way up to 10.2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10.2. Now what we're going to do is we're going to use a trapezoidal approximation. So we're going to make trapezoids out of this. So I'm going to grab my little line maker. We're going from 1 to 4. So here's my first shape. There's my first trapezoid. Now let's draw my second one. And then I've got my third one. Really concentrating here. There's my third trapezoid. We're going to find the area of those 3 trapezoids. So let's see if we can remember how to find the area of a trapezoid. The area of a trapezoid is base 1 plus base 2 divided by 2. You average your bases and then you multiply this times the height. That's the formula for the area of a trapezoid. So this first trapezoid, this is base 1, this is base 2. My height is right here. So let's take a look at these numbers. So the area of my first trapezoid is going to be 2.6 plus 3.4 divided by 2. That's averaging those bases because this was 2.6 and that was 3.4. And then we're going to multiply that times the height. The height is from 1 to 2, or 1. That's the area of this very first trapezoid right here. Now the second trapezoid would be 3.4 plus 5.8 divided by 2 times 1. Average the bases times the height. I know it's sort of weird me saying height here, but the height of these trapezoids connect the bases. Then we're going to do one last one, and that is 5.8 plus 10.2 divided by 2 times 1. So let's see if we can actually answer this one. 2.6 plus 3.4 is 6. 6 divided by 2 is 3. 3 times 1 is, well, that's 3. So the area of the first trapezoid is 3. 3.4 plus 5.8 is 9.2. Divided by 2, that's 4.6. That's the area of the next one. And then 5.8 plus 10.2, well, that's 16. Divided by 2 is 8. So I have 3 areas to add, and I get 15.6. Now notice in this example, I can't really find the exact value under the curve because I don't know how it was connected in here. So I had to use an approximation. So anyway, that's Riemann sums, a formal name for just estimating area under the curve. We've done left, right, midpoint, and trapezoids, and so you'll practice this tomorrow. See ya.